What you've seen here is a 5 kVA hybrid inverter charger made by Vevor or Vevor, live at the command center of JW Solar USA in Minnesota. We've done some videos from the past on Vevor or Vevor, Vevor, and they turned out pretty good on a 3 kilowatt 24 volt inverter charger hybrid. So this thing is huge. This is how it looks like. Alright, I think this is how it looks like. Let's take this plastic out and see the actual width and length. How wide it is. Look how big it is. This is the units right here, made by this company. They've been making a lot of stuff. So here we go. So if I use the tape and try to measure across from this end diagonally, is 23 inches. So it's about exactly 23 inches. If we go this way, it's almost 11 and a half. And go back this way, about 5.5 to 6 inches, 5 3/4. And I noticed something, that they make a huge improvement on the product. That's a big heat sink at the top here compared to the previous ones. It has the vent where like Mppt solar tend to have, it sucks the air from the bottom and push it all the way up. So I don't know if this is how this one operates, but you can see the massive heat sink up here to cool things, components. So these are the mounting holes right here. See them right there to hang this machine. And it has some soft keys. So if you tend to have the habit of pushing buttons really hard, you don't know how to stay away from force, well, you're in trouble, because these buttons don't tend to last too long if you keep poking them too much or too hard. You tend to have problems in the near future. But let's go back here and show the inputs. Okay. All right. You can see the AC input and output, the bottom and the top. The terminals are all the way inside, and it has a breaker right here. This is a 230 volt. This is a high frequency inverter. It has the 2 fans in there, and the PV, if you look all the way straight, you see it right in the say PV all the way up here. The wire goes all the way in, the DC, and the PV is up here. If you look all the way, you see the terminal in there. So this is the on and off position. It has some vent underneath all the way to the top. So that will tell you not to mount this machine flat without having, although it has some little bushing or a stud right here, a bump that's supposed to suspend it from the let me put this one down, suspend it from laying flat. See that? And it's different from the other designs. So now you can able to probably take the input, the air intake from here and throw it from on the side. Look at those big, Trudeau was a choke or something, whatever you called them, in there. And it takes air from here. It takes air from the bottom. So guys, it's more things they've done to the 5 kVA. And let's go to the specs here. I know you're gonna be watching this in a side way, so look at that. It's a 5000 VA, so it's a volt amp. This is not made by Mppt Solar, to get the record straight. And the solar DC open circuit is 150 volts DC. The rated power, which is the charge, is a 3000 watts. The output, this is the rated output, is a 5000 VA, so volt amp, so it's equivalent to 4000 watt. So you can use the input for DC, like your battery, and it's a requirement of about 87 amp battery to run this guy. Okay, so it's 230 volts, 50 hertz, 22 amps. So 22 amps is putting out on the AC. So you need about approximately a 25 amp breaker or 30 amp breaker that goes to your disconnect or your sub panel, whatever. You can go with 25 amp. If you don't get 25 amp, you can use a 30 amp breaker. So don't try to use a 20 amp. It's not gonna work. It's gonna work, but it's gonna trip. So the output, DC output, is about 54 volt DC, and it can go from 10 to 60 amps. So it might be a 60 amp charge controller inside this guy. So we just have to check it out when we connect it and see exactly, because you can choose what amperage you want to charge your batteries. See, the model is a MP5 5 kVA-60, because the 60 is a 60 amp charge controller built in this thing. So the color is a silver black. Operating temperature is 0 to 55 degrees Celsius. So, and you know, these machines are made randomly everywhere now, China, whatever. So most of the original, some of the thing is it's not even Mppt Solar is incorporated with a company that makes these guys, but they just slap the labels on them. See, so they make a different thing. People are just buying, I think, the copyrights or whatever you call them. IP27. We have to power up this thing for you guys to see, and it looks a little bit, it's kind of slick. Finishing here, it's nice. Made by that company, Vevor. This is the display panel. It's gonna be giving you that annoying sound when you started, that beep. So be prepared for that, and just turn all the alarms or all the beeps and noisy stuff, then I think you're gonna be okay with that. Unless you can able to live with that, with the noise, you like the noise, because anytime the sun goes down, it will do that thing. And when the sun is coming up, it's gonna do the same thing. So yeah, we're gonna put it in try. The only thing, excuse me, we don't have much stuff here we can test it with, but I have a step up and step down transformer, which is a 5 kVA. So a 5,000 watts, not 5 kVA. This is a 5 kVA, which is equivalent to 4,000 watts. So the transformer has a buffer to go all the way to that 4,000. So I don't know what's the surge capability, because this guy is supposed to surge 2 times the capability, 2 times the capacity. So 2 times the capacity. So we have to go through this stuff, and stay tuned for more video coming up from this. And we're gonna see the 5 kVA with the massive heat sink made by Vevor right here at JW Solar USA. It's pretty interesting. Okay, I've done reviews on this Mppt solar. You can check my playlist and see since they came out, especially in the US. I was lucky to be one of the guys who done some videos. So Vevor is a well-known brand here in the US. I think they have a branch, I think it's California or something, and they have a huge variety of things that they produce, you know, come to washers and all that stuff, and power machines, power tools, and different things that they already expand their range for certain things that you know, like well pumps, you know, submersive pumps, different things. So I'm not afraid, I'm not scared about these guys here. I think they try to, I don't think it's not UL listed. If you look at it here, they have their own certification, these companies here. You know, I think it's just a ROHS. I think those are the kind of certifications. It's not UL listed, and this is not a grid tied. It doesn't backfeed any power back to the grid. This is just a standalone. It's an off-grid equipment. But stay tuned, and I will see you on the next video how we're gonna power this guy with a 48 volt system. And we want to try these batteries, this lithium iron phosphate batteries. You've seen it on my videos. I have some active balancers here, and all the other one on the side. You see there's a little light in the corner right there, and they still do their balancing. Well, these are set up in a 24 volts configuration, so it's just a matter of taking this guy, this end, and slap it back to here, because we have a negative on this other side, and we can put it here, connect the series. Okay, that gives us the 48 volts, and we can use the bus bars here to connect to the inverter. All right, we'll see. These are 40 amps per cell, 40 amps each. Each cell is a 40 amp, so 3.2 or 3.2 volts. I think you can charge up to about I think it's a 14.4, 14.0 for 12 volts. It's about something, so about 56 to 58 volts on 48 volts. So we have to take the balancers off, because the balancers are just for 24 volts. So I have these batteries wired in 24 volts, and with the bus bars I use for the Volkswagen e-Golf batteries. So that's when I open it up. These are the bus bars. I just utilize them so we can able to connect this battery back into a 48 volts easily, because it's configured for 24. So we see, you'll see the video coming up. Stay tuned, maybe tomorrow on Saturday, everything goes up. Saturday, November 18. I will try to bring up a video. Okay, so see how this guy is gonna work in conjunction to this. So it's a 40 amp here on 24 volt because it's 40 each cell wired in series. The voltage goes up, the amperage goes down, and the same as here. So 40 here, this string, 40 there, it's 24 volts. So would I have like 80 amps on 24 volts the way I set them up? But if I go 48 volts, this one is continued here, and the voltage goes up, the amperage stay the same, and we only have about 40 amp battery bank. But it's going to be really small and powerful battery bank just for a test and see how everything works. Like I said, we're going to take the balancers off, so we don't want to blow them up because they're not designed for it. Like and subscribe. Bye for now.